Do you know that there is a problem with the EIGRP multicast? Okay, as we know that EIGRP uses the multicast to send the updates, extend the hello packets as well. But there is a problem with the multicast. Let me explain you how. So let's say example, you have a router number one right now, and this is the switch we have, and this is my router number two, and this is my router number three, and this is my router number four. Assume it right now. I want to form the neighborship with every guy, right? So what I can do that I'm gonna enable the EIGRP on every interface, right? So I'm gonna, let's say example, this guy's IP is 101, this guy's IP is 12, this guy's 13, and this guy's 14. And the submit I'm gonna use the 191.1.0/24, right? So if I'm gonna enable the EIGRP protocol on this particular interface, this particular interface, this particular interface, and this particular interface, in that case, what happened? They will join the multicast group, right? They will join the multicast group. The multicast group is 224.0.0.10, right? So that's my multicast group we have. Under this multicast group, right, is we have a router one, we have router number two, we have router number three, and router number four. Now, what they will do that they will dynamically form the neighborship. Though they will send the hello packet, they will also send the hello packet. If the neighborship criteria will match, they will form the neighborship. Same thing is going to happen with the R3 and R4 as well. I'm not denying there is a problem right now, but think about it. What happened if there's any attacker comes in the picture out of 5 over here, and they will also going to enable the EIGRP on this particular interface, and if they are participating into the all the neighborship criteria, then R5 will form the neighborship with all the router. And if R5 will form the neighborship with all the router, in that case, what happened? All the routing information will be there on the router 5. So this attacker will get all the information of your network as well. First challenge, the multicast is a scalable, not in every situation. Second problem, think about the service provider we have, right? And this is my site number one. We have site number one, site number two, and site number three we have. And of course, right, you have a L2 VPN scenario right now. And normally in the L2 VPN scenario, what happened? You are gonna connect. You're gonna extend your layer 2, right? So this guys are 101, this guys are 102, and this guys are 103 right now, and they are they are separated by the service provider. What happened if the attacker also comes over here, and they will also put the 171.104. So right now, what happened? All this router 1, router 2, router 3 has enabled the EIGRP protocol on this particular interface. After enabling, what happened? They will be part of this multicast group right now. So eventually what happened, router 1, router 2, and router 3 will be a part of the same multicast group. So they will form the neighborship dynamically, right? What if this guy also going to enable the EIGRP on this particular interface? Then it's gone, right? Then R4 also will be part of this group, and R4 eventually form the neighborship. Maybe this R4 is present in a different location, maybe in the different countries as well, different cities as well, right? But eventually if they have a connectivity, right, they can form the neighborship. So there is a mini, challenge we have with the multicasting. Now you may have a question, hey Lord, do you know one thing? I can enable the authentication, I can see. That's a totally different thing. I'm not denying that. Okay. But what if you don't have authentication? And what if the attacker will get the authentication part as well? Then that's a major challenge we have. So to avoid this multicast, or we can call it the dynamic neighborship, what we can do that over here, we are gonna go with the unicast neighborship. So if you see that, so the multicast, right, that offer you the dynamic neighborship, right? What I'm gonna go to that, I'm gonna use the unicast way to form the static neighborship, and that's how, right? That's how I'm gonna make the EIGRP as a more scalable protocol. Now, to do the static neighborship, you have to use the neighbor command, right? You have to use the neighbor command. Normally in the multicast dynamic neighborship, what happens? You just need to put the network command, network 192.168.1.0. Whatever the interface will be present in this particular subnet, all that interface will be enabled in the EIGRP protocol, and all that interface will be gone in the multicast group as well. What we can do that, I'm simply gonna use the neighbor statement. So when I'm gonna use the neighbor statement, in that case, what happened? I'm certainly gonna define, hey, look, I'm only gonna form the neighborship with you, not the other person. Have a look at this topology right now. I'm gonna dictate this guy, right, on the router one, hey, I'm gonna form the neighborship with you. I'm gonna form the neighborship with you. I'm gonna form the neighborship with you, and vice versa as well. So I'm manually defining the neighborship. So when I'm gonna manually defining the neighborship, it's give me the more security. And that's how the EIGRP static neighborship comes in the picture. So let's have a look. This simple topology I made it over here right now. And router 1 and router 2 we have, right? Interface, let's configure the IP address will be 10.112.1/24 and no shutdown. Same thing on our router 2 as well. Interface 0/0 IP address will be 10.112.2/24, no shutdown. And I have a loop back as well. Remember, loop back is a logical interface. They don't have any MAC address. And no need to put the no shutdown command. Good one, right? And if it's loop back, you can get a bunch of loop back on a router, right? No limitation. Of course, there is a limitation, right? But whatever the requirement you have, you can make it. So if you see the range right now we have, you can make a loop back of this range, right? All good. So we have done this one. Now the thing is that when I say I'm going to enable the router EIGRP right now, I'll say the EIGRP router ID will be 111. I'm going to say the neighbor to 10.112.2, right? What else? Put a question mark, right? Bad one, right? So they are asking you, hey, you cannot do that like this way. They're asking you to give the interface, right? How do I reach to this guy, right? So when I'm saying that, hey, I want to reach to this guy, I need to define what is my local interface right now. I want to reach to this guy 12.2 via my local interface 0/0. That's good. Now, if you see right now, what I can do that, I'm going to enable the debug EIGRP packets. That's fine. And capture this link as well. Okay. Do you see the any EIGRP packets? Right? Normally, the EIGRP packets are being exchanged at every 5 seconds. Do you see the any EIGRP packets? No. The reason is that if you put the command show IP EIGRP topology table, my EIGRP has been enabled. Show IP EIGRP interface, my interface has not been enabled in the EIGRP protocol. Tips: neighbor command and redistribute command is not enabling the interface into the routing protocol, right? I'm talking with the EIGRP perspective right now, don't come with the BGP, okay? So EIGRP neighbor command and the redistribute command is not going to enable the interface into the protocol. So if you see that, it's not enabling it. So if it is not going to enable it, then how would I form the neighborship? So to enable the interface into the EIGRP routing protocol, what you have to do that, you need to use the network command. So what we can do that, I'll say the router EIGRP number 1, come on. And I say the network 1.0 or 12.0, I think so, 10.112.0 and wildcard mask and done. So now you can see that my interface has been enabled and I'm sending the hello packet. Interesting part, if you see this hello packet right now, it's pure unicast. I dictate that you need to form the neighborship with the 12.2. So I'm sending the pure unicast neighborship. Normally it is a multicast, right? But normally it's a unicast neighborship right now. So 10.1, 12.2 is 12.1 is sending the packet to the 12.2, and this is my same EIGRP hello packet. There's nothing changed over here. Same key values that you can see, the K1 and K3. Now same thing, what I can do that on R2 as well. I'm gonna run this command, router EIGRP number 1. So let's do the step by step. So I first need to give the route ID 2.2.2.2.2, and I'm gonna say that network will be 10.112.0, right? And that's all. And I'm gonna say that neighbor 10.112.1 and 0/0. So now they will form the unicast neighborship. Got it? So you can see that do show IP EIGRP neighborship. I have our neighbor right now, and you can also put the detailed keyword. Look for the neighborship in the detailed behavior as well. Interesting. If you see right now, whatever the message is being exchanged, all are the unicast, right? 12.1, 12.2, 12.2, 12.1, all the packets are the unicast, right? Now what I can do that, even I want to exchange the route. Let's example, I'm gonna router EIGRP. I'm gonna exchange my 2.0.0 prefix. That's my loop back. I'm gonna send this update. What you see right now, the 12.2 is sending the update to the 12.1. It's a unicast update, and that has a routing information. Same thing I got, of course, the acknowledgement is a unicast, right? So if you see I also received control mark, and I also received the unicast That's of course, that's a pure unicast packet. So that's how you can configure the EIGRP static neighborship. I'll put this command line. Hold on. I'll stop this debugging you all, and I say that show run section EIGRP. You can see that I have a neighbor. So this command is required network statement, right, to enable the interface, and then I'm going to say the neighbor to LR2 as well, and same thing on R2 as well. Do show run section EIGRP as well, right? That's good. Thank you so much. Bye bye.